Okay.
Yep.
So I'm just going off of the quiz. I just kind of copied and pasted everything.
Mhm.
The first one I got was the law of large numbers. Right?
For
And-
less than 8, or
It says, what is the name of the important statistical result that guarantees that the sampling distribution of the sample mean X will be normal if the sample size is large enough?
what is
Number 1.
Yeah. Law of large numbers.
yes.
So the number 2 is a central limit theorem.
Wait. Oh yeah. No, that's both. Yeah.
Because number 2 then is the name of the important statistical result that states that when the sample size is large, the sample mean will be close to the population mean. That's
right.
Yeah. And then number 3, what is the last 2 that were categorical?
Yeah. Well, no, not the last one. Just the middle one.
I guess, yeah, it's just the middle one.
So not age and years. Randomly.
Yeah, it's just the middle one because age in years, age is not categorical. What's the other one? Quantitative. There it is. So age is quantitative.
Yeah.
Are you having a party?
Yeah, they're having a party at my house.
Well, tell them they need to share the cake.
I know.
Okay. The mean IQ test score in the US is 100.
Yes.
Is that's the next one? Okay.
I think it is. It should be.
So parameters and statistics. I said 100 is the parameter because it's representing the population. 112 is the statistic because it is the manipulation of the results.
Yes.
Okay.
Right. And then, so this one so number 5, I wasn't sure if it was stratified or clustered. So Gotham, which is supposed to be Gotham City.
So wait, go back to the IQ one. Which one was that?
The IQ, that is in the quiz. That's question 3 in the quiz.
Yeah, question 3. So did we discuss on that one and we decide?
Yeah, 100 is the parameter and 112 is the statistic.
Okay, I must have missed that. Sorry.
Actually, Susan, while we're going over this, you probably will want to pull up your group quiz.
Okay.
Because these are the same questions. So you'll want to punch them in as we go.
All right.
Yep.
You pull that up then. Hold on. I always have to adjust the screen size to get the start quiz to come up. Really annoying. True.
Yeah.
Okay, which of the following? So just the randomly selected brand. So 100 is the parameter, and that one's a statistic. Okay.
Yes.
Okay, here we are. So Gotham City has 4 distinct neighborhoods. The property values are very similar, blah, 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 blah. Like I said, I didn't know if this would be more of a stratified or a clustered sample.
So I said stratified because okay. So a stratified one, they divide them into groups. And then they take a random sample from each group. Where a cluster sample would be like that grade one, the one that they talk about, the 4th grade. That's a cluster sample.
Right.
Because they divided them by districts, and then they randomly selected a district. And then I'm not going to be able to explain it very well. There's more random sampling of the groups with a cluster sample.
Mm-hmm.
So they divide them into groups, and then they randomly select a group instead of randomly selecting from a group. Does that make sense?
Yes.
Okay. So that's the difference between cluster and stratified. So question 4 is stratified.
Stratified.
Yeah.
So then 5 is clustered.
Cluster. Yeah.
Mm-hmm.
Okay, then 6, I put simple.
Mm-hmm.
Simple random sampling.
Yep.
So then 7 was also simple random sampling.
And is that a special interest group is conducting a survey?
Yeah.
Sure.
I said a stratified random. What did you get, Josh?
I'm thinking it's about a stratified random as well.
Okay.
I wasn't sure on that one.
So they took a list of registered Democrats and selected a simple random sample of 100 people. And then they took a list of registered Republicans and selected a simple random sample of 100 people.
Yeah. So they made groups.
Yes.
So they made a group of Democrats, and then they made a group of Republicans, and then they randomly selected from those groups.
Okay. Okay. So number 8, for the mean, I got 4.771.
That's what I got.
Sorry, number 8, you say?
Yeah.
4.771?
Yes.
Okay.
And then for 9, for the standard deviation, I got 1.912.
Yep.
Okay.
What questions do we have? Ew. Yeah.
Did everybody make their histogram for question 10?
Yes.
What if I should do that in there?
Let's see. Yes, I created histogram.
So on this one, just a question on it. I know it's like SPSS and stuff, but like what, and then it's just with descriptive statistics, what was like the dependent? Was it just like the amount on it, or when you compare the means and stuff, or?
Yeah, I selected amount. Yeah.
Okay, that's what I was thinking.
Yeah.
I just want to make sure I was on the same page.
Sorry, that's me beeping.
That's okay.
Okay, so let's see. What was, scroll down here. So for A, I guess it's number 11.
Mm-hmm.
Did you get negative 0.165?
Yes. For 12, I got 0.681.
Yep, that's what I got.
Okay.
Do you want to go around again? So we'll do Josh and then Susan and then me.
Yeah, let's. Is this file up? Do we need to pull it up, or is it just there? Oh, okay. Never mind. I see it.
Oh, okay.
13.
Yeah, I thought it was a SPSS for a second.
What did you get for 13, Josh?
Give me a second. think
Okay.
about this. I'm just thinking about this question already. So.
Okay.
Sorry, I'm going to be coughing like I'm dying again. I have a feeling I'm going to be doing this for the next couple weeks.
How are your antibiotics?
They're working. I don't cough as much at night, so I get to sleep.
Yeah.
I'm thinking, wouldn't it be the mean? I'm thinking it's between that or the variance. I'm kind of stuck on that one just a little bit.
Well, remember, so what quantity is equal to the sum of the numbers in the squared deviations? If you remember, like in lesson 3-ish, 3 or 4, there was all those big boxes, and then so you took your sample minus the standard deviation, and then you had to square it, and then you took all those and you summed them up. That was called, I believe that was called the variance.
That sounds about right.
And this one actually, the answer is, John just texted me. He said he won't be able to make it. So the answer is actually none of these. So I had to go back through and actually add them up. So when I went back through and actually added them up, I got 0. And so I knew that 0 couldn't be the mean, couldn't be the standard deviation, and couldn't be the variance. So I just used process of elimination to say it's none of them.
Right.
And so if we go back.
That's weird. That's something that kind of confused me, I guess. I didn't think it confused me when I looked at my notes, but now it does confuse me when I look at more of my notes.
No.
So I guess the sample variance is whenever you take that sum of the squared deviation and then you put it in, then you divide it by your population minus 1. That's then the variance.
Right.
In a different one I have here, everything I have here, like the standard deviation squared, which is, I guess, the sum of all these things. When it comes up to like 2 point, one of the things we did, it came out to something like 2.9167 in my notes.
So if you go to lesson 3 and then hop down to.
It was the roll of the dice. That
and the part that I looked at was lesson 3, 5.1.1. And then if you scroll down a little ways after the comic strip. Oh, wait a minute. Just a second, and I'll tell you the right one.
Okay.
Where did it go? I just had, oh, there it is. Okay. So go down to, you see a little graphic that says step 3 and then D. So you see the 5.1.1, which is calculating the standard deviation by hand. And then you see step 3D. And then below the box and whisker is your one of the tables, and there's column 1, column 2. So what they want us to add is the deviation from the mean.
Hold on, I missed something.
Wait a minute.
There's deviation. There's 3D.
What quantity is equal to the sum of the numbers in the squared deviations column? No, I just got lucky with that logic because that's not right. I'm with you guys.
So here, sample variance, step 5. The number you computed in step 5 to call the sample variance is a measure of the spread in data. It is a very nice theoretical property. The variance plays an important role in statistics. We denote the sample variance by the symbol S squared.
So I think that the sum of the squared deviations is just the sum of the squared deviations. I don't think that it means anything else.
Okay.
Because in order to get the variance, you have to divide it by n minus 1, and in order to get the standard deviation, you have to know the variance. So the sum is important because you need the sum in order to get the variance, in order to get the standard deviation.
We would also need to know the population.
Yeah, they should do that as well. Whoops, did we just lose her?
You there? Where'd you go?
Yes, I don't know what happened.
Yeah, I don't know what happened.
Sorry. Okay, so it's none of the above.
Yeah.
Yep.
All right, number 14. So I got 38.075.
So the standard deviation of the temperatures, is that what that one is?
So how did you get that one? I couldn't remember. You get that one.
Let's see, what did I do? I did something. I took what did I do? I wrote down everything else I did.
Because wouldn't it be the value minus the mean or something like that?
Right. Well, you don't do that yet. Well, that's
Are you question 14?
Yes.
Yeah, question 14.
Okay, go ahead, Susan.
Sorry, I'm trying to figure out how I got that.
Okay. I got a different answer.
Let's see, how did I get that? Standard deviation. Oh, that's not it.
Okay, it's 37. For the cells.
How did I find that?
So
what did you get, Ashley?
I got 0.715.
0.715, you say?
Mm-hmm.
Okay. And how did you get that?
So I found the mean, and the mean is, I didn't write the mean down. So I gotta find it again. Hold on one second. So the mean is 38.0.
Oh, that's what I did.
Yeah, that's what, okay, so the mean is 38.075.
Okay.
So then I took each of those values and subtracted the mean. So you do 37.91 minus the mean, 37.25 minus the mean, 38.98 minus the mean, 38.16 minus the mean. And then you square each of those.
Right.
Okay.
And then you
add those up, don't you?
Yeah, you add all of those up and you divide by n minus 1. So you add them all up and you divide by 3.
Okay.
And then you take the square root of that.
Oh, wow. Okay.
Okay, I get it.
All right.
So,
Thanks.
hold on. Oh, I can't stop coughing. It's annoying.
Sorry.
Okay, so 2.237, and then you took that divided by 2, 3, 4, divided by 3.
Yeah, so the sum of your squared
And square root that.
deviations. Yeah.
So
Yep.
0.864.
Mm-mm. 0.715.
That's what it should have been, huh?
Yeah.
Hold on. 1, 6. Weird. Let me add that up. 3, 8, 7 equals that divided by 3. That and the square root. Huh. Yeah, I get 0.864.
So what are your numbers as you're going through it? Did you make a chart?
Yeah.
So
my numbers going down
yeah.
are 0.783, 0.681, and then 0.766, and then 0.007.
So your first and your third numbers are incorrect.
Okay. I know my first one, every time I would do it, it would come out differently. It was weird. The first one would be 0.027.
Yep. That is correct.
Oh, gosh. One more. All right, much better.
That makes me sad.
I'm so
I
sorry.
know. It's okay. It's not your fault.
You're right. It's my daughter's.
Yes.
Gave it
I
to me.
guess so.
Let's blame the kids. I'm on board with that. Let's do it.
All right.
So then what should the third one be?
The third one's 0.819.
819. All right, then let me try that again. 0, 2, 5 plus 1.819 7. That divided by 3. Square root. There we go. 0.715.
Yeah. Yep.
You know what's funny about that? Before question 16, it actually has the answer in the chart under the standard deviation of 0.715 already.
Oh my gosh, it does. That is funny.
Just thought I'd
Didn't
point
even
that
notice.
out.
Where does it say that?
After question 15 in the little chart. That is called using the test as a resource.
God.
Yeah, I know.
I am generally really good at picking those out.
I know, same here.
Like anatomy and physiology, I swear one of the only reasons I passed the physiology portion of that class was because I would go through and my first sweep of that test, I would pick out the things I knew and then I would go back through and figure it out from there.
Right. Mm-hmm.
So hard. Okay, so question 15, false.
That's
The
what I
standard
was thinking.
deviation always has to be positive.
Yes.
So number 16, I didn't quite get an answer.
They just want to know which one is the most accurate, basically.
So would that be the one either closest to 1 or closest to 0?
Closest to 0.
So external.
Mm-hmm. Yep. And that just is because the deviation is smaller. So you want the one, the most consistent or the most accurate is not even accurate's the wrong one. Most consistent, the way they have it worded, is going to be the smallest deviation, the smallest gap.
Right. Okay.
Okay. Got it.
Okay.
On to 17, right?
Mm-hmm.
Did anyone get the answer 6 on that one, or is she looking like it for a specific percentage?
For question 17?
Yeah.
It's actually the third quartile is the 75%.
Okay, that's what I thought. 0.75.
Oh no, I'm sorry. It's 8. So the 75% is the top of your box plot or the top of your box.
Yeah, it was 6 or 8. I wasn't sure which one it was. So
yeah, it's 8.
Okay. I was like, there's no percentage there, so
yeah,
can't really put it there. Okay. Between 4 and 8.
Okay. What bird did I think I got 60, isn't it 68%? Because it's
Yeah, shouldn't it be 68% on this one?
standard deviation. If 6 is your mean.
No, this is just looking at the percent that's going to be between 4 and 8 of that box plot. So using the box plot and not a bell-shaped curve, not a normal distribution, just the box plot.
So wouldn't that be like 50%?
Mm-hmm.
Okay.
Does that make sense, Susan?
Yeah.
Okay.
Mm-hmm.
So we just put 50.
Mm-hmm.
Yep.
Okay. I wish they would make up their mind.
No
I know.
kidding, right?
I have to read it really carefully. So these next two, I could not figure out.
These three questions look pretty hard. Is there any like problems? Let me check if there's anything in the textbook about this. I don't know if there is though, but I'll check and see.
Okay.
So I got numbers for this, but I don't know if I did it horribly, horribly wrong. Because I did something, I was like, oh yeah, this makes sense. And then I started like adding more numbers and go. No. Put clothes on.
Go put clothes on. So how did you do it? Did you
Put clothes on.
Sounds like something I would say.
Not something I would say either.
Just have her put a shirt on or something. Please. She had a mask on, but no shirt.
So we're looking at between 1.59 and 2.52. And we know that each of those are 2 standard deviations away from the mean.
Right. So when I did that, I just took the difference between the 1.59 and the 2.52.
Yeah.
And divided it by 4.
Ow. Yeah, that makes perfect sense.
Why would it be 4?
But because it's 2 one way and 2 the other way.
Oh, okay. So you add
But
those up and then it's 4.
it would be divided in half. And then we should have just divided it in half and then added that half like to the 1.59.
Oh, okay.
So 1.59, and then go the other way. 2 minus 1.59 equals 0.93 divided by 2 equals 0.465 plus 0.59, which, yeah, so the mean would be 2.055.
Let's check and see. Just 1 second. Pull out my calculator.
So then the standard deviation would be 0.233.
Okay.
The standard deviation would be 0.23.
233.
So you took the 2.52 minus 1.59 divided by 4?
And then I divided it by 2 to find the mean. And then you divide the mean again by half, and that's your actual standard deviation.
So you divide it by
2. If they went 2 standard deviations over. So your mean minus 2.2 standard deviations gave you 1.59, and then the mean plus 2 standard deviations gives you 2.52.
Mm-hmm.
Wouldn't it be the difference of that divided by 4?
Right.
Thank you. Now, get out of here.
So you did.
And that's how you got the 2.055.
Now go to bed. Go.
I gotta love kids.
So
Okay.
You have to stay here for about a few months.
Okay.
For about 10 months.
Okay. Thank you, doctor. Now go away.
Here's a sticker.
Thank you for the sticker. Good night.
okay, see. So you found the middle between them. That's going to be your mean. And then you found the difference from each side. I just made it way too complicated.
Okay, seriously? Now you? Part 2. Hold on.
So
Go.
I think it has the kidney.
You had your murder mystery. Go.
But I didn't get my husband kidney.
You know better.
Okay.
Go. Good night. Good night. Go. Okay. So
I figured out question 21, just process of elimination, because I couldn't figure out 19 and 20.
yeah.
So I just looked at it and I went, yeah, the only ones that make sense are the last set.
The 1.82.
Mm-hmm.
yeah, wrote down the last number wrong, but I had the 0.1823,
Mm-hmm.
2 point something. I just wrote that down. Is that your phone making weird noises again?
Yeah,
Something.
it's Skype. It's my Skype.
Right.
Okay.
All right, so 22.
So what was 20?
Oh, sorry.
We estimate the standard deviation on number 20.
Oh, so the standard deviation is just the difference between your mean and your either of those ranges.
So it's 0.233.
Mm-hmm.
I'll figure that out, how to get it once I get there. All right.
22. So that one I didn't get either.
This part?
Yeah.
Let's see.
Like, what is the probability? Oh, wait, maybe I did. This is a different question for me. Oh,
So,
okay.
is it asking us to find the z-score to this? Is what it
No,
sounds like to me.
probability. So wouldn't it be 50?
Yeah. And it's actually 0.5.
Why they put that?
I guessed, and I got it right.
So it's not like 0.5000.
0.5 is what I put down.
Okay.
Below 600.
Okay, that one. Did you get 0.481?
Mm-mm.
Okay.
So this one you'd go 600 minus the mean, which is 542.3.
Wait, 600 minus what?
The mean,
Mm-hmm.
which is 542.3.
542.3. Okay.
And then you divide it by your standard deviation, 120.54.
120.54.
Joking. Don't do that. Hold on just a second. 600 minus 542.3 equals
That's what you do, though, right?
57.7 divided by the square root.
Of what is it? 600?
The square root of 120.54, which is the standard deviation.
Okay, so let me start over here. I just lost it.
Nope, that's not right either.
That should be.
600. Okay, let's see. Minus 542.3 divided
Well,
by.
how many, we don't have a population, though.
Right.
Square
So wouldn't
root
it just
of-
be that 600 minus 542.3 divided by 120.52 or 54?
Not, you have to still square root the 120.54.
Why?
Hold on. Let's see.
I'm pretty sure. I'm still.
Let's see. Divided by 120.54 divided by the square root of. Nope, not that one. Okay, let's see.
Because I just took this, like you take the z-score of what you get when you do that, and then you put it in the applet.
Nope.
Yeah.
600 minus
So don't you just put in the applet your z-score of 0.47.
Yeah, 9.
So what was the Z-score you got? Just to see.
Did you get 0.316?
I haven't yet. I'm still trying to figure it out.
Wait, for probability for z-score?
Yes.
For 23, question 23.
The z-score for question 23,
Oh, that's below. Sorry. Hold on.
I got the z-score. I got 0.479.
0.479 then?
Yeah, but that's the z-score that you would punch into the app.
Right. And then what it's really asking is what's below it.
Right.
It seems like it's 0.684, isn't that right?
Yeah.
Okay.
Yeah. And then you're going to just switch everything around. Highlight above that for question 24.
Okay, I see.
Well, we're on 23 though.
Right.
Then what was 23?
So if it's shaded below, then it's 0.684.
Uh-huh.
And for question 24, shaded above, it's 0.316.
Find the GMAX. So 25, I'm kind of lost a little bit on that one.
So this one, you select the lowest third, and then in the area at the top, you put in 0.1 for the 10th percentile.
0.1. Okay.
And then you have your z-score. So then you used your z-score at the bottom, so negative 1.282,
Huh.
and you just work backwards.
So are we talking negative then for this one?
Yes.
Yeah.
It should be negative.
So negative 1.282, and then you multiply
120.54.
standard deviation, yeah, and then you add your mean.
Mm-hmm. So actually, for that, did you get 387.768?
Yeah, and it wants you to round to the nearest whole.
So
388.
Uh-huh.
Okay. Okay.
So then the z-score, so Josh, the z-score for the 90th percentile is going to be the exact same, just the positive.
Okay, so you just take the positive side then on that.
The positive 1.282.
Times 120 divided by whatever it is. I don't know.
Times 120 plus 542.3.
So that'd be like, okay, I see 387. Let me check the other way around. I'm still in the negative mode.
Okay.
No, you're fine.
I'm doing a lot better on this than I thought I would. So
wouldn't that be 697 for question 27?
Question 26 is 697.
Oh, okay.
Actually, 696.
I thought it was 697 because it's rounding to the nearest whole.
So I got 696.448.
And it's 696.5, I think.
Let me redo mine then. Oops, I forgot. Oh yeah, that was a positive. Oh, yeah, there's that 5. Okay.
So this one.
So then question 27 is 461.
Yep, that's what I got.
And then question 28, you do the same thing, but you put in your third quartile, which is going to be 0.75.
So you just put in 0.75 for 28?
No, you do the same thing that you did for 26 and 27,
Right.
but
the
you're
whole
using 0.75 instead of 0.1 or 0.9.
I think what I did for that, what did I do for that? Oh, okay, I know what I did for that. Okay. Yeah, I just added I put in the 0.27 and got the z-score for it, which was negative 0.674. And then you just work backwards again.
Oh, yeah.
For what question?
For
So
number 28,
Uh-huh.
you go up to the applet,
Uh-huh.
you put in 0.25, and you kind of click on the
Okay. And you just work backwards?
you click on the last one because that's kind of where you're at. And then you put in 0.25, and it gives you a z-score of negative 0.674.
Okay.
And then you do the working backwards thing again.
So what did you get, Susan?
For the first quartile, I got 461.
Okay.
And then for the third, I got 624.
Perfect. Okay, yeah, that's what I got.
$24. Okay.
Bless you.
Thank you.
Bless you.
Oh, thanks.
Oops.
So 29 is kind of like a trick question.
Kind of is.
They already give you the mean.
Right. So the mean is going to be 542.3. 542.3
Yeah.
On 29.
for 29.
Okay.
Then the standard distribution, isn't that when you just take your normal standard distribution divided by the square root of the sample?
Sample size, yeah.
Yeah.
So 31.12, how many decimal points? 3.
3.
1, 2, 3.
So what did we decide on 30?
31, that's what it is.
31.123?
Yep.
Yeah,
Okay.
for 30.
Okay.
And then 31 is, you're just going to finish the problem. So 600 minus,
The 542.3? Or is it a
yeah,
different one?
Yep, 542.3.
Minus 542.3. Okay.
And
No,
then you're going to divide that by number 30. So 31.123.
Okay. But don't you do a square root on that one for that one, or is it just leave it blank?
And that's essentially what we did in number 31. It's that same.
Because don't you divide that and do the square root of 15?
Yep, that's what 31 or that's what number 30
Okay.
is. It's that 120.54 divided by the square root of 15 is that 31.123.
Okay. So what did you guys get then for that?
For number 30?
Yeah, 31.
31. I got 1.854.
And I got 0.0319.
Oh, all right. Let me do it again.
Yeah, I got a different one. I got like 7.18 or
Oh,
something.
all right. So 600 minus
542.3.
542.3 equals 57.7 divided by 31.123.
Uh-huh. And then I divided that square root of 15. I should try it. And I still got the same answer. I got like 7.180.
And then you have to stick that in the applet though.
Oh, okay. But doesn't it not go above 7 though?
Say that
It
again.
doesn't go above 2.
Yeah, I thought it was going to go above 2 or 3.
I know. Well, the Z-score that I got was 1.854.
That's what I got.
And it's
How did
what's the
how did you-
probability of it going greater than 600? So you put it in the far right one, and you stick in your Z-score, and it gives you 0.0319.
But I think Josh is struggling to get. Okay, so Josh, walk us through what you're doing. Start us out.
So what I did, I just took the 600, the
Uh-huh.
minus the 542.3,
Okay.
and then I divided that by the 31.123, like you said, right?
Mm-hmm.
And then I divided that the square root of 15.
Okay, but don't do that because we already did that to get the 31.123. We already did that step.
Okay. So where do I go from there?
So you stop when you divide by 31.123. That's where you stop, and that's your Z-score.
Okay. 1.854. Gotcha.
Yeah. Yep.
And then let's see what the question said. Would be greater than 600. Did you guys get 0.032 or?
0.0319.
Yeah.
Yeah.
You round up to 0.03212.
0.032.
0.0312.
Mine says, oh, right. Oh my gosh. Yeah.
I thought it was like 0.032 was what it sounded like.
Yeah.
0.0312.
0.032. Yeah.
Yes.
Okay.
Yes. Oh, gosh.
Should we see if we got 100?
You got the answer in your face, but you just can't seem to. Doesn't translate. You're like looking at it. It's like it's right there. All right. Should we go for it?
Yeah.
All right.
Let's see what we missed. If we have any.
Let's hope
I
not.
just let's see. I'm looking at mine. I just submitted it.
So far, so good.
1. 100%. So
Yay!
we did good.
Okay.
Awesome.
Awesome.
Well, good luck, everybody, on your exam.
You as well.
And yeah. Wednesday. I can start the thing on Wednesday.
Okay.
Okay.
Sounds good.
Okay.
I'll try to hurry. I'll
Josh,
take a test.
are you okay with all the processes that we did today?
With me? Yeah, I'm gonna work through it when I get back. I'm just like I'll have tomorrow and Wednesday. Wednesday I'm probably gonna take the test in the day, but have tomorrow to review the test.
Okay.
Make sure I understand everything.
Okay.
So I'm just gonna go through those numbers and figure out how we got them again.
All right.
So
Well, let us know though if you have any problems.
okay.
It's not that I can guarantee will be help, but you know, we
Sure.
might.
You might. It
Yeah.
probably not be successful with me, so yeah, that's for sure.
We will try. Ashley, you there?
I am.
Okay.
I am just punching all my answers back in.
Did you miss any?
Well, when I did it the first time, I did it before our group,
Uh-huh.
and there were some that I left blank.
Right.
And so I just wrote the answers down to those as we were working through as a group.
Okay.
But up until this point, I've been looking at my first attempt. Does that make sense?
Yeah.
Yeah.
Okay.
Yep. At least they give you 2 attempts.
Yeah, this wasn't bad.
Not terrible though.
I am the hardest question for me was the 2 standard deviations away. That one right kind of in the middle. I think it was question 20.
Mm-hmm. Yeah, that one I just kind of, it was one of those, it just is kind of answers.
Yeah. And your logic on that was perfect. I made it way more difficult.
If it helps, I think you're the one that told me how to do it in the first place.
Oh, good. I'm glad. Yay!
Yeah.
That's nice.
Okay. Well,
That's good. Appreciate it, guys.
yeah.
Problem.
John, we wish you luck.
Same here.
And
If you haven't already.
I hope that he sees this.
I don't think he really watches them.
Oh,
John? I don't
Yeah.
know.
Who knows?
I don't know.
Well-
He does what he wants.
John, if you do see this, we wish you well. And we'll see you on
Wednesday.
Wednesday, hopefully.
Yeah, hopefully Wednesday.
Yep.
All right. Cool.
All right.
So, Susan, you'll turn it in and we'll see you guys then.
All right. I appreciate it.
Yay.
Okay.
Thanks, guys.
Bye.
Good luck.